Hi, this is Dr. Sheena here. Today, our topic for the presentation or the discussion is direct filling gold. So, direct filling gold is actually a material that was used from the ancient time where it was used as restorative material. So, we need to know the properties, the qualities wise we select gold as a restorative materials and the method of compaction of this material into the cavity. So talking about the properties of pure gold, it is a very soft material which is having a brittle hardness number of of 25. It is having high tarnish and corrosion resistance property. Whenever it comes in contact with the oxygen or the noble gases, it doesn't form the corrosion products. It is one of the noblest of all the metal. It is ductile and malleable, so it can be actually beaten into sheets and also drawn into wires. It is weldable at room temperature, that is called as the cold welding. So the pure gold fuses at the temperature of, so this is 1063 degree centigrade. So this is the temperature at which the pure gold starts to fuse. So the carat of gold that is used for the restoration is like 24 carat of the gold is actually used for restoration. Now talking about the classification, they have three important classification. That is the gold in the form of a foil, gold where we do electrolytic precipitation. Third is the small powdered gold. So talking about the foil, it is of various type. It is in the form of a sheet, it is in the form of a rope, it is in the form of a cylinder, laminated foil, platinized foil and corrugated foil. And while the case of electrolytic precipitated gold, they are of matte gold, matte foil, and also it is a combination of gold and also calcium alloy, that is called as electroalloy. So this is actually electroalloy, that is gold and also calcium combination forming actually the electroalloy is there. Next is the powdered gold. The powdered gold is very small particled gold which is called as gold dent, that is having a size of 15 micrometer, and it is otherwise called as Williams EZ gold. So these names and this chart is actually very important. The gold calcium alloy is also called as electroalloy since it is electrolytic precipitation is done. Powdered gold is like the EZ gold. Powder is EZ gold, also called as gold dent. Now talking about gold foil is actually one of the earliest form which was actually used. They are in the form of a book of either 1 by 10 or 1 by 20 of those sheets are there, and they are of in two number, either they are numbered of 4 or number 3. Number 4 means they are having a net weight of 4 grains, and number 3 means it is having a 3 grain weight, and they are supplied in the size of 4 into 4 inch, while the case of 3 is actually supplied as 3 into 3 inch. Other sizes which are available include 20, 40, 60, 90. So this is in the form of a book. We know that we have a book and inside the pages are there. The foils are also arranged as such, and we'll be actually taking each one. Next is, so this is actually normally the like how we get the gold foil, and we can actually for compaction or for easy rolling and all, we can divide either by half, by 1/4, 1 by 16th, etc. Division can also be done. First is the form of gold foils. First is plain gold foil. So plain gold foil is actually the basic product which can be cold welded and modified into any form. So the plain gold foil is actually the easy manipulative and easy workability. So the proper disadvantage is like it is often soft, so it requires time for the manipulation as well as the mass formation. What is corrugated gold foil? Sometimes the gold foil is placed in between leaves of paper, and we'll be actually igniting it or we'll be actually burning it. So what happens is like the papers actually get charred off and more of a corrugated gold is actually formed. More cohesive or more, it's not cohesive, it's very stronger gold is actually formed. And this is more cohesive than the plain one. When compared to the plain one which you had, it will have a property of more cohesive type. So this concept was actually found out when they had a great Chicago fire in 1871, where the gold was actually heated in the great Chicago fire, and it had a greater property. So corrugated gold foil means we'll be placing the gold in between the papers, and we'll be igniting the entire thing, and the paper will actually charred off, and we'll get a very good corrugated cohesive gold foil. Next is platinum gold foil. Platinum gold foil is like two gold in between two gold we'll be actually placing the platinum. So the platinum is sandwiched between two gold foil. The percentage of platinum is actually 15%. Why we add platinum? Platinum often increases the hardness of the restorative material. That is why platinum is added to the gold foil. So these are actually used in ground repairs and also areas where extensive stresses is imparting. There we use this platinum golded foil. So that was the next classification of gold foils. So what is the disadvantage? Since it is very hard, it is really difficult for its finishing and polishing, right? Now next is laminated gold foil. So what we do is like we will take 2 to 3 gold foil, and they will be actually kept in different direction, and we will be actually cold welding it. We will be pressing it. So we will get a newer gold foil which is having the gold arrangement, or the direction of the gold is in different direction, so that the forces acting on the area will be dissipated easily. The laminated gold will be more stronger in order to actually compensate for the masticatory forces which fall on its surface. So this was about gold foils. Normally, first is the platinized gold foil is there, platinum is added, corrugated gold foil is there, we'll be heating it, laminated gold foil is there, where 2 3 4 like we'll be joining together, so that we'll get the gold foil which have different ingots moving in different direction. Next is type of the preformed foil. There are two type of sheets are there, cohesive and non-cohesive gold. So what is a cohesive gold? Cohesive gold is a pure gold which is not having any surface contaminant. It is very free. What happens is like normally our air contain oxygen and oxidizing agents. So what happens is like gold have the property to form corrosive products on its surface. So the gold which does not have any impurities, any gases on its surface, which is very purely made, is called as cohesive gold. Only a gold which is free from pure impurities can be easily condensed and welded in the temperature. Now what is non-cohesive gold? Sometimes in the surface of a pure gold, some oxygen or some gases get actually get attracted to the surface. There are certain gases which is really difficult to remove, like there are some non-volatile gases which get actually adhered to the gold surface. So even after heating, this non-volatile gases won't go from its surface. So for protection, what we do is like we will be purposefully adding a layer of ammonia on the surface of actually gold foil, because ammonia is actually highly volatile gas. Even though we heat the gold on heat, it will get evaporated. But some non-volatile gas, if it get attracted to the gold surface, it won't go. That is why we deliberately like add ammonia to the surface of gold foil to prevent other non-volatile gases coming and actually attaching to its surface. This is called as non-cohesive gases. So intentional coating is done with actually 18% of ammonia. Why? To prevent the adsorption of other non-volatile gas to its surface. Okay. And other shapes include ropes, cylinders, laminates, pellets, etc. Rope will be elongated form. They will be actually applied in the cavity, and we'll be actually condensing it. Normally ropes, cylinders are actually taken from a 4 into 4 inch sheet. We'll be actually using to produce ropes and cylinders. Again, cylinders, pellets, we are taking from that 4 sheet foil, and there are various shapes and size: 1 by 32, 1 by 64, and 1 by 128. These pellets are actually placed in the cavity. We'll be doing the condensing. Next is electrolytic precipitated gold. As the name suggests, electrolytic precipitation is the method where we use for producing electrolytic precipitated gold. So the powder is actually formed into shape by sintering procedure. Okay, sintering causes self-diffusion between particles when they comes in contact with each other, right? Electrolytic precipitation is of three type. Matte gold is there, matte foil is there, gold calcium alloy is there. So matte gold is actually crystalline electrolytically precipitated gold that is actually placed formed into strips. So we know that the electrolytically precipitated gold is when it is made into strips, they form actually the matte gold. Now what is matte foil? When we actually sandwich the gold foil with the matte gold, that is the matte gold to matte gold, we'll be actually using the normal foil, gold foil. So that is actually called as matte foil. To the normal paper we had earlier explained, to that we will be actually attaching the matte gold. Now another is gold calcium alloy. What is gold calcium alloy? The gold to gold actually calcium was actually added. What is the requirement of adding the calcium? You can see that the newest form of electrolytic precipitated alloy is called as gold calcium alloy, also called as electroalloy. Why calcium was added? Calcium was added to actually increase the strength of the restoration, and also to what is the mechanism? By dispersion strengthening is the process. Okay, and how many percentage of calcium is added? It is 0.1 percentage of the calcium is added. Okay, as I said, matte gold are those electrolytically precipitated which are in the form of a strip. And what is you can see in this image. So what is matte foil? We'll be using the normal gold foil onto which the matte gold will be placed. That is a matte powder will be placed. So that is matte foil. Now, there is something called as the third one, the powdered gold, also called as golden, also called as EZ gold. So, it is otherwise called as spongy gold. As you know, there is something called as atomization procedure. That is a machine where we'll be actually allowing the gold to enter into that machine, and it will be actually precipitated and deposited as small powdered particles. So the particle size might range from 1 to 4 mm. So atomized and chemically precipitated powder are first mixed with gold wax. We'll be mixing with wax, and we'll be actually heating that so it form a cohort particle. So what is the advantage? It's like, since it is very small and powdered, it is easy for compaction, and there will be less of a void formation, etc. EZ gold is actually a product of this powdered gold that is formed by small particles blended with the organic indicators compressed into small cylinders. So it is actually the precipitated gold where it is actually compressed together to form small cylinders. Now, this is another table that is very important. So, to summarize, we studied the gold foil, the electrolytic precipitated gold, as well as the powdered gold. In each that, we need to study what is the difference. Now, where we apply all these things? First is the matte gold. Matte gold is actually applied in bulk filling. Bulk filling, we apply the matte gold. where we use the gold foil. Gold foil were the classification first one. It is mainly used for the surface veneering or the external surface veneering. We use the gold foil. Where we use the matte foil. Again, foils are actually, it is paper like, so it is used for veneering. Electralloy is electrolytically precipitated gold, is mainly used for the core and finishing. So just memorize this chart. Next is like how to manipulate DFG, that is direct filling gold. So we know that normally the gold might not be pure. It might have lot of cohesive, like no, lot of oxygen, lot of oxidative products or corrosion products on its surface. So we need to remove all that gases from its surface. That procedure is called as degazing, heat treatment or annealing. What is that treatment? We'll be taking the gold, we'll be heating in the temperature at about 600 degree Fahrenheit to 1300 Fahrenheit. This is to remove all the impurities from the gold surface so that when we join to gold, they will adhere very easily. If voids are there, it will be difficult for them to actually adhere properly. So normally studies have shown that reversible gases like oxygen and ammonia are readily removed at a temperature range of 900 to 1300 degree Fahrenheit. So desorption or degazing or annealing can be done in two methods. One is piece by piece method. Piece method means there will be gas. That gas will be actually applied in piece and it will heat up and remove the excess of the gas. Bulk method means there will be a tray. So we'll be placing all the gold in that and we'll be inserting to the annealing machine. So piece by piece method is mainly done with the help of a alcohol flame. You can see this is the normal alcohol flame used, and in the middle zone, that is actually the blue zone is there where we will be actually placing the gold and heating it. You can see it is an open alcohol flame. Only the middle portion of the flame or high energy reducing zone, that is called as a reducing zone. The blue zone is actually used for heating purpose, and normally the fuel inside that is either alcohol or acetone free alcohol is preferred. So each piece we will be actually holding for about 3 to 5 seconds in that alcohol. So this is the method. You'll be applying it for 3 to 5 seconds. And next is actually mica over a flake. This is actually a tray, a sheet of mica onto which all the materials are actually placed, and we'll be actually heating it for, you can see in this image, we are heating it for 5 minutes is there. This is the mica tray mounted over the alcohol. Next is there is something called as electrical decasing. It is like our oven we have seen, right? What we do is like we'll be actually placing a lot of our gold particles, and it will be placed on the electrical decontaminator for 800 degree Fahrenheit. That is the temperature. So the advantage is like it is not time consuming. The other case we have to do individually. Here it will be actually done at a particular controlled temperature and also time. Allow the operator to work alone also. Now, next is condensation or compaction. Once we have heated it and removed all the like unwanted oxygen and unwanted gases from its surface, now we need to place within the cavity and condense it. So what are the types of condenser? There are hand condensers. It is like our hammer. We'll be placing it. We'll be using the hand condensers and mallets. And pneumatic condensation is there. Electronic machines are there. So the condenser shape, based on shape, there is actually a round is there. There is parallelogram condenser, and there is actually food condensers are there. So mode of condensation, as I said, hand condenser is actually using the oldest method of condensation where we'll be applying the pressure by our hand. Pneumatic condensation is based on the vibration. It is a vibratory condensation where the material will be compacted. Electronic means the electronic machine is actually used for condensing, which is working at an intensity of 2 O's to 15 lbs and at a frequency of 360 to 3600 cycles per minute. Next is we have various condensers, as I said, that is round condenser for initially placing and condensing, and food condensers is there, that is for actually you can see this is the cavity onto which the gold is actually placed. So round condensers, also called as Bionate condenser, is used in the initial restoration phase where we will be placing the gold. Port condensers are mainly used for the KO surface margin condensation and the surface hardening procedure. And there is parallelogram condenser that is used to create that bulkiness of the restoration. Oh, this is the hand instruments. Right. Now, what are the principles of condensation? So simple. Think this is the cavity. So always the first layer of actually gold is placed and we'll be applying a force at an angle of 45 degree. So that is a method how we apply the force. The force is actually applied at an angle of 45 degree. The next step is like onto the existing gold we'll be applying a force of 90 degree. So initially 45 degree, next 90 degree. So that is the line of angle or the angle of forces, how we should actually apply the forces. You can see in this image, initially we will be giving a 45 degree angulation pressure. After that, to the existing gold we will be applying a force, line of force of 90 degree. You can see in this image, see 45 degree and after that 90 degree, 90 degree, right? Now there is an important thing called as stepping. What is stepping? This is the image showing stepping. See, once we actually apply one layer of gold at the base of the cavity, and just think that the next layer is placed, there is something we have to do called stepping, where we'll be using a condenser and we'll be using a pressure such that this gold, the pressure is made such that the condenser move half the distance of the first condensed gold. Then only it will give a non-void or void free condensation. So stepping means we have to apply the first layer, then second layer. Condensers are used such that it goes half the distance into the first layer. That is called a stepping. What is the use of stepping? Stepping is mainly used to actually remove the voids and give a uniform like a layer of composite, gold on the particular area. So no voids, maximum adaptation, denser restoration. That are the significance of a stepping process. See, this is the stepping process we'll be applying at each layer diagrammatically. So this is an image showing a improperly condensed gold. There will be irregularity seen. So the pellets is also similarly located in the cavity and we'll be giving the certain equal pressure. You can see in this image, see the pellet is placed first. First of all, we'll give a 45 degree angulation and next a 90 degree angulation of actually force to the existing this thing. Then we'll be forming a stepping bridge formation, etc. So as I said, this is very important. 45 degree to the cavity wall, 90 degree to the cavity wall. The first is like 45 degree to the cavity wall, then 90 degree to the cavity wall. This is important. What is stepping? As I've already explained earlier, stepping, the other name of stepping is shingling. This is very important. Shingling is the other name of stepping. So we have to condense such that it go half or 1/4 of the already condensed gold, right? General steps in insertion include, first of all, there is actually tie formation is there. Tie formation means the connection of opposite point angle to the opposite point angle on another side is actually called as a tie formation. Banking means we will be covering each walls. Banking means we will be covering each walls from its wall to from its floor to the KO surface angle. That is called as actually banking. Next, shoulder formation is actually completing the connection between the two area. So these are the general steps of gold placement. Now force is always inversely proportional to the square of the diameter. Inversely proportional to the square of the diameter. So it means that smaller the material, means just think that we are having a diameter of 2, diameter of 3 for the condensers which we use. So what will be the force? Force is directly, it is inversely proportional to the square of the 2 square is like 4. It is almost uh, 1 by 4, and force is like 1 by 3 twos are 9. So just think what happens is like here the value is more. So smaller the diameter means the force will be more, right? As the diameter of the condensers increases, the force decreases. And the best marginal integrity is by which material? It is by gold. And the KO surface for gold is like 30 to 40 degree. These are the differences that you need to keep in mind. The KO surface angle for amalgam is like 90 degree. It is called as butt joint. In the case of a gold, it is called as it is about 30 to 40 degree, right? And another KO surface angle is like slip joint or lap joint, which is for cast restoration. So this was the basic things for actually a gold. Even though it is a very vast subject, the normal question that has been asked is like the what is annealing, what is platinized gold, corrugated gold, what is the size, it is a 4 into 4 and all, and what is the angulation at which the force is actually applied while we condense the gold. So hope you had a nice class. Please go through this and we'll see in the next class. Thank you.